Okay, hello everybody, Sanjin here with another little update of sorts. I'm working on VEX at the moment, and I'm really loving it. It's very precise, very easy to use, and I've just got a very simple program here, pretty much the shortest amount of code with which you can do something reasonably cool. The libraries that come with it have a whole heap of functions that make your life a bit easier, but I like to start teaching my students from first principles. So here's a simple example. While 1, that's like a while true. This is like a forever loop. So this is inside a forever loop. And you basically take the sensor reading from the ultrasonic, which is your distance, and it's in centimeters. And then you feed that distance as speed into the motors. I came up with this little equation, distance times 8 minus 200. So what that does is, well, I think it's better if I just show you what that does. So I'm going to compile that. Should work. Fix formatting. I'm already perfect. Download to robot. So, technically let me actually maximize the video. Bong bong. Hi there. And if I'm forceful enough, I'm pretty sure I could knock the robot over, but that is pretty cool. And actually, let me stop that and show you a bit of line following. So I'm going to stop that. So let's have a look at the line following. Now, here we have a program where what you've got to understand is that the simplest way to follow a line is to the robot, when he's essentially on the line, he can turn right, and when he's not on the line, he can turn left. And when turning right means turning the left motor, and turning left means turning the right motor. So effectively, all you need to do is have this if statement in a forever loop, and have some sort of threshold that decides if the robot is over the line. Now, how best to figure out what this threshold is going to be? Well, you simply take two sensors. You put one above the line, you put the other sensor above the carpet, and you add them up, half the value, then you have the exact in-between value of those two sensors. So essentially at that point, you take this line track, you put it inside, as I said, a forever loop. This is a while true. This is the start of the forever loop. This is the end of it. And basically you say, well, you know, track the line unless distance is less than 15. So, at least in theory, this thing should just run up to the box. And it should have different speeds depending on whether, say, I am standing in front of it or not. So, let's just have a look. I mean, I want to make sure that it works. So I'm going to put my foot in front of it. And what that should do is ensure that it doesn't move. But this is also going to allow me to check the threshold. There you go. Distance is less than 13. It basically tells you where it is. It's stopping all the motors. The threshold is 25.68. You can have the value of the two sensors. 25 is right in between. So everything tells you that this is going to work reasonably well. Oops. Or not. Or not. So yeah, that did not work exactly as planned. But things rarely ever do in robotics. And so we have made a bit of an adjustment. As you can see, the line is a lot thicker. And what I'm hoping is going to happen is that it won't sort of skip over the line like it did. And yeah, that it's just going to run up to that box and slow down as it approaches it. And we're going to try it a few times. So I'm going to compile, download or upload I guess we upload to the robot. And here we go. That's pretty good. And if we move this forward, he would slowly follow. Push it to the back. That is pretty good. I'm gonna stop, maybe maximize, and try one more time. This time it's hopefully gonna run really fast. So I actually need to press start and then maximize. There you have it. Basic line following and ultrasonic sensor orientation using VEX. Well, I'll be making a couple more as I make more advanced programs that basically pick stuff up and put it into designated areas. But for now, goodbye and see you in another video.